In this lecture, we are going to discuss question 3A and 3B, each of 3 marks question. Question 3A based on the activity and question 3B based on the solving questions. All questions are from question bank provided by Maharashtra State Board. We have the first chapter, that is Similarity. Look at once the question 3A. First question we have triangle ABC. AP is the perpendicular on BC. BQ is the perpendicular on AC. BPC are the point of collinearity. AQC be the other point of collinearity. Then show that triangle CPA is similar to triangle CQB. If AP equals to 7, BQ equals to 8, BC equals to, we have a 12. Then AC equals to. In triangle, we have a CPA and triangle CQB. Look at the triangle. First triangle we have CPA, so that this red shaded triangle ultimately we have CPA, and next triangle we have the CQB, so that CQB be the blue shaded triangle we are having. This much triangle be the CQB. We have here angle CPA, which is congruent to an angle CQB. I am writing an angle CQB because each of 90 degree. Now angle we have ACP, which is congruent to an angle, we may have BCQ. So I am writing BCQ because the reason behind it, we have the common angle. So once two angles of one triangle are congruent to corresponding two angles of the other triangle, then we can say given two triangles are similar by using angle-angle similarity test. So once the given two triangles are similar, then their sides are in equal proportion, so that we are having here CP upon CQ, that to be equals to, we may have AP upon BQ, and that is equals to, we may have first and the last letter, that is AC upon BC. So look at the activity we have given here, AP divided by BQ, that is equals to, now we have the denominator as a BC, so whose numerator we are having as a AC. So that AP upon BQ, that to be equals to, we have AC upon BC, corresponding sides of similar triangle. Try to replace by their value. We have the AP is 7, so 7 divided by BQ is 8, so that 8, that is equals to, we have to evaluate for the AC, so keep that AC as it is, divided by value of BC, we have a 12. Now to evaluate the AC, try to shift 12 from RHS to LHS. 12 is the multiplier, after all shifting it becomes a 12 is the divisor, after all shifting it will become a multiplier to 7 by 8, so that value of AC we have 7 by 8 into 12. Now 4 2s are 8, 4 3s are, we have a 12, so that we are getting now 7 into 3 divided by 2, that is the value of AC, 7 3s are 21 divided by, we have a 2. That means we are getting a 10.5. Now we have to fill in the blank over here. So once we use the cross ratio test, so that we are getting 7 into 12, that to be equals to, we have a 8 into AC or AC into 8. So next fill in the box we are having as a 8. AC into 8 equals to 7 into 12. Once we shifting the 8 from LHS to RHS, so that we have 7 into 12 divided by 8. 7 into 3, that becomes 21 divided by 2, we are getting 10.5 exactly. Now look at the second activity. We have it is of the form, a line parallel to one side of a triangle which intersects remaining two sides in two distinct points. We have given that in a triangle ABC, line L is parallel to the line BC, so that we have, this is the line L which is parallel to the line BC, and a line L intersects side AB in point P and a side AC in point Q. AB in P, AC in Q. So we have given that AP divided by PB, that is equals to, we have AQ divided by QC. So let us try to Actually it is not the given data. Here we have to prove this one. AP divided by PB equals to AQ divided by QC. Let us have the construction. Draw the segment CP and the BQ, CP and the BQ. So now we have the proof. It is of the form triangle APQ. Look at the triangle AP and Q. We have this uppermost triangle, blue shaded one, and the triangle PQB. Look at the triangle PQ and B. This green shaded triangle. We have the triangle PQB. Those two triangles are having the same height. That means once we are drawing the perpendicular from point Q on its opposite side, supposed to be we have QS be the perpendicular. That means the given two triangles APQ and BPQ both are having the same height, that is the QS. So we have equal heights. So what about their ratio of area? So ratio of area of a triangle is equals to ratio of their corresponding bases. So look at the first triangle for APQ. Once SQ be the perpendicular drawn on the AP, so AP be the base of that triangle. So first fill in the box, we have the AP divided by the other triangle we have BPQ. Once the perpendicular QS drawn on extended BP, so that the BP is the base and SQ be the height. So we have PB or the BP be the base of other triangle. Now look ahead for the next two triangles. Now once we are assuming the triangle APQ and the PQC, look at the triangles carefully. Now we have APQ means the uppermost triangle, blue shaded one, and PQC means this lowermost triangle, the green shaded one. Once we are drawing the perpendicular from point P on its opposite side, we might say the AQ or the AC. We called it as the PRB, the perpendicular now. So the triangle APQ having the height PR and base is AQ, while the triangle PQC having the height is PR and the base is CQ. So that we have here, once the given two triangles having the same height, that is the PR, so ratio of their area is proportion to their bases. We have one triangle, first triangle, that is the APQ, whose base is now the AQ, because PR be the perpendicular drawn on the AQ, so AQ be the base, divided by we have base of the triangle PQC. Look at the triangle PQC, PR be the perpendicular drawn on the extended CQ, that means QC or the CQ becomes the base. Already we have given the QC be the base of the triangle PQC. Now triangle PQC and the triangle PQB. Look at the triangle carefully. Which two triangles we have? PQC means this red shaded triangle, and we have PQB, that means this blue shaded triangle. So those two triangles now, once a PQ is parallel to the BC, once we are drawing the perpendicular, supposed to be from point P on its opposite side, or we might take here, once PQ be the common side of those two triangle BPQ and CPQ. So once we are having the perpendicular now from point B actually on its opposite side, that means the extended QP, so that suppose we are calling it as a BD be the perpendicular drawn on the extended QP, so that BD be the height of both triangle, because the distance between parallel line, ultimately the perpendicular distance at anywhere, is constant, so that those two triangles ultimately having the same base as a PQ and the same height as a BD. So once they are having the same base and the same height, so that we can say those are having the same area. That means area of triangle PQC, that is equals to we have area of triangle, first triangle PQC, second triangle we have PQB. Let us call it as now the equation number 3. Look at the equation 1, 2 and 3. Those by using those three equations we are getting area of triangle APQ divided by area of triangle PQB, that to be equals to now area of triangle we have as per the equation number 2 APQ divided by area of triangle PQC. Once the given ratios are equal, So let's try to equate their RHS so that we are having AP divided by PB, that to be equals to now AQ divided by QC. Hence we have our proof. This is the basic proportionality theorem we are having as an activity. Look at the activity number 3. We have from the figure PQ is parallel to the BC. This PQ is parallel to, we have given the BC. AP equals to, we have x plus 3. PB equals to, we have x minus 3. AQ equals to, we have x plus 5. And QC equals to, we have x minus 2. Then complete the activity to find the value of x. So in triangle PQB, once we have given PQ is parallel to the side BC, then we can use here the basic proportionality theorem. So as per the basic proportionality theorem, we can say that whatever be the segment made by PQ on AB and on AC are in equal proportion. That means we can write AP divided by PB, that to be equals to, we have AQ divided by the QC by using basic proportionality theorem. Now try to replace by their values whatever we have given in the data, so that we have now AP equals to x plus 3, PB equals to, we have x minus 3, AQ equals to x plus 5, while QC equals to, we have here x minus 2. Use the cross ratio test. That means we have to shift the x minus 3 and x minus 2 from LHS to RHS, from RHS to LHS respectively, so that x plus 3 into we have x minus 2, that to be equals to x plus 5 into we have x minus 3. Now once we use the distributive law among them, we have here x plus 3 into x minus 2. Once we distribute x over the bracket, next to it 3 over the bracket, so that we are getting x square minus 2 into x becomes minus 2x, 3 into x we have the 3x, and 3 2s are 6 plus minus minus 6, so that we are having x square minus 2x plus 3x becomes x minus of 6. So that here we have LHS is of the form x square plus x minus of 6. Look at the RHS carefully. We have it is of the form now x plus 5 into x minus 3. Try to use the distributive law. Distribute firstly x over the next bracket and next to it 5 over the next bracket, so that we are getting x into x is x square, x into minus 3 is minus 3x, 5 into x becomes the 5x, and 5 into minus of 3 we have minus of 15. Now after all simplifying, x square minus 3x plus 5x we have plus 2x minus of 15. So that x square plus 2x minus of 15 already we have given. Now here x square from opposite side and same sign getting cancelled. Next to it, once we collect all x's towards one direction, that means we remained with here x minus 6 to be equals to 2x minus of 15. Once we shift 2x from RHS to LHS and minus 6 from LHS to RHS, so that we are getting x minus 2x to be equals to minus 6 becomes now the plus 6, 6 minus 15. X minus 2x, both are the like terms, easily added, easily subtracted. So x minus 2x becomes minus of 1x means the minus of x, and 6 minus 15 we have here minus of 9. Minus minus getting cancelled or gives us plus, so the value of x here we are getting a 9. So hence here we have all three activities from question number 3a. Look at the first question from question 3b. We have it is of the form: there are two poles having height 8 meter and 4 meter on plain ground as shown in the figure. Because of sunlight, shadow of smaller pole is 6 meter long. Then find the length of shadow of longer pole. Now keep in mind, at a given time the angle between sunlight and the height of pole, or we might be says the pole, that are congruent. That means we have here angle BAC is congruent to QPR, and also we well known height is always perpendicular to the ground level, so that angle PRQ and ACB are also congruent because both are of 90 degree we can say. So by using the angle test, given two triangles are similar. Okay, so I am writing at start, in triangle we have the PQR and triangle we have the ABC. Once we are having here angle at start QPR that is congruent to an angle, we have a BAC that is given to us. At the same time we have the angle between the sunlight and the height of the pole that are congruent. Next to it we have angle PRQ that is congruent to an angle ACB. Both are, or each of them are 90 degree we can say. So once the two angles of one triangle are congruent to corresponding two angles of the other triangle, then we can say that given two triangle PQR and triangle ABC are similar by angle test. Now once the given two triangles are similar, we well known once the triangles are similar, then their corresponding ratio of their corresponding sides are equal, so that we can say here the PQ divided by we have the AB that to be equals to, we are having next side is the QR which is corresponds to BC that to be equals to PR corresponds to we have the AC. Now once here we have to evaluate the value of X, and we have given here the PR and the AC values QR, and we have to evaluate for X means the BC value we have given it as X. So let's try to consider the first and the last ratio to be equal. So let us try to consider now. We are having among the three equal ratios, the second and third ratio we are considering. QR divided by BC equals to we have the PR divided by AC. What is the value of QR? We have a 6. BC is X that to be equals to we have PR is 4 and AC value we have the 8. Now to evaluate value of variable X, try to shift 8 and X from LHS to RHS, RHS to LHS, so that we are getting 6 into 8 that is equals to we have X into 4. To evaluate the value of X, try to shift the 4. 4 is the multiplier. After all shifting it will become a divisor to 6 into 8. So let's try to simplify now. We well known 4 ones are 4, 4 twos are 8. So we might remain with the 6 into 2. 6 into 2 becomes a 12. So the value of X we are having a 12. Now look at the second question. In triangle ABC, B, D and C are the collinear points. BD equals to 7, BC equals to 20. Then find the following ratios. First ratio we have area of triangle ABD divided by area of triangle ADC. So for finding the area of any triangle, we required base and height, because basic formula we have half times base into the height. So look at the first triangle we have ABD, this red shaded triangle we might have, and the ADC, this blue shaded triangle we are having. So once we are drawing the perpendicular from point A on its opposite side BC, let us call it as the AE. So AE be the height of both the triangle. Keep in mind, once AE is perpendicular on BD, BD is the base and AE is the height for the first triangle ABD. While once AE is the perpendicular on extended CD, so AE is the height and CD be the base for the other triangle. So that I would like to say here triangle ABC, ABD actually, ABD and a triangle we have the ADC having same height. Once the two triangles are having same height, then we can say that their ratio of area is equals to the ratio of their corresponding bases. So that we might have here area of triangle ABD divided by area of next triangle we have ADC, that is equals to ABD is a base we have BD divided by ADC is a base we have CD. So what is the value of BD? Look at the given data. We have BD is 7. And now what is the value of CD? Once the points are collinear, B after D after C we have, among them BD value is 7 and overall BC we have given 20. So what is the value of CD? CD becomes now BC minus BD, that means 20 minus 7 we have a 13. So the value of CD we have a 13. So that should implies the area of first triangle we have ABD divided by area of second triangle we have ADC, that is equals to 7 divided by 13. Look at the second ratio. Is in the second ratio we have to evaluate area of triangle ABD to ABC. Look at the both triangle. I am writing triangle ABD and a triangle we have ABC having same height. Because look at the first triangle we have here, that is the ABD, that is red shaded triangle, and now ABC becomes overall blue shaded triangle. So once for the ABD, AE be the perpendicular drawn on the BD, so BD is the base and AE is the height. Look at the triangle ABC, once A is the perpendicular drawn on the BC, so that BC is the base and AE is the height. So both the triangle are having same height, that is the AE. So what about their ratio of area? So that I am writing area of triangle ABD divided by area of triangle ABC is equals to, once they are having the same height, so area is ratio of their area is equals to, we have ratio of their corresponding bases. So for ABD we have BD be the base, and for ABC we have BC be the base. So value of BD we have given 7 and value of BC is 20. So that here we can say is now area of triangle ABD divided by area of triangle ABC, that to be equals to, we have 7 divided by 20. Hence we have the solution for the second sub question. Now look at the third sub question. We have to evaluate the ratio of area of two triangles that are ADC and ABC. So that instead of using now ABD, we have to use the ADC, that red shaded triangle, and other triangle we have the overall blue shaded triangle, means the ABC. So again those two triangles are having the same height, that is AE. So I am writing triangle we have ADC and a triangle ABC having same height. Look at the both the triangles carefully. Once we are talking about the triangle ADC, AE be the perpendicular drawn on the extended CD, so CD be the base and AE be the height. For the triangle ABC, AE be the perpendicular drawn on the BC, so BC is the base and AE is the height. So those two triangles having the same height, that is AE. So what about ratio of their area? Ratio of their area is equals to ratio of their corresponding bases. So for first triangle ADC we have CD be the base, and for the triangle ABC we have BC be the base. Now value of CD we have a 13 and value of BC we have a 20. So that we can write here area of first triangle ADC divided by area of second triangle we have ABC, that is equals to, we are getting a 13 divided by a 20. Hence here we have all three sub question from the question number second. Now look at the third sub question from question 3b. In the given quadrilateral PQRS, side PQ is parallel to side SR, AR equals to 5 times AP, then prove that SR equals to 5 times PQ. Now look at here, we have given the segment AR, AP, SR and PQ. Those are the sides of which triangle? First of all, identify that. So those are the sides of triangle. We have APQ and ARS. That means this blue shaded and the red shaded triangle. So once we are proving here, or we have given at start here, AR equals to 5 times we have the AP. Once we shift the AP from RHS to LHS, so that we are having AR divided by AP, that is equals to, we have a 5. And once here we have to prove for SR to be equals to, we have 5 times PQ. That means once we are shifting the PQ, so that SR to be SR divided by PQ, that to be equals to 5. Once those two equations are having same RHS, we can equate their RHS. Ultimately here we have to prove for AR divided by AP, that to be equals to, we have SR divided by PQ. Then we may having our proof, that is SR to be equals to 5 times PQ. So how to prove that AR divided by AP equals to SR divided by PQ? We well known AR, AP, SR, PQ are the sides of those two triangles APQ and ARS. So first of all, try to show that given two triangles are similar. Once the triangles are similar, then we might say the corresponding sides are in equal proportion. So let us try to write. Firstly, we have given segment PQ which is parallel to the segment SR, so that there is a formation of angle is in the rotation of Z. Those two angles are said to be congruent because those are alternate angle we are having. So we have PQ and SR be the segments that are parallel. So which two angles formed here is in the rotation of Z, that are, I am writing PQA which is congruent to now an angle we are having RSA. Why? Because those are the alternate angles. And now once two lines are crosses each other, that means intersecting here in point A, which two lines we have? First line is the PR and next line we have the SQ, that are intersecting in point A. So vertically opposite angles are formed that are congruent. So which two vertically opposite angles we are having? That are PAQ and angle we have RAS. Those two angles are congruent because that are vertically opposite angles. Now once the two angles of given one triangle are congruent to corresponding two angles of the other triangle, we can say that here triangle, which is that first triangle we are choosing APQ and the other triangle we are choosing ARS, that are said to be similar by angle test here. Once the two triangles are similar, then their corresponding sides are in equal proportion. So which two sides we required here? So first relation we have AR to be equals to 5 times AP, that is given to us. So we required AR and the AP, so that we can write here AP divided by first two letters together divided by first two letters of the other triangle, that are AR, that to be equals to, we have to prove for the SR equals to 5 times PQ. So SR means the last two letters. So last two letters of the first triangle we have the PQ divided by we have the RS means the SR. So try to replace now as per the given AR equals to 5 times AP. So try to replace now AR by 5 times AP, that is equals to we have PQ divided by the SR. Now AP and AP from numerator and denominator of LHS getting cancelled. So we have 1 by 5 equals to PQ divided by the SR. So once we shift here 5 and SR from LHS to RHS, RHS to LHS. So 1 into SR, ultimately we are getting the SR, that to be equals to 5 into PQ, we have 5 times PQ. Hence we have our proof. Hence proof. Now look at the fourth question. In triangle ABC, point D is on side BC. BDC are the collinear point such that angle BAC is equals to angle ADC. Then prove that CA square is equal to CB into CD. Now look at here, CA square we can write CA into CA while CB into CD as it is. Now once we shift the CB as well as one of the CA from RHS to LHS, LHS to RHS, so that we are getting CA divided by CB, that to be equals to, now we are having CD divided by CA. Now let us try to evaluate CA, CB, CD and CA are the sides of which two triangles among the given. I would like to separate out the figure is of the kind. First triangle supposed to be, we are having the triangle ABC. We have A, next to it somewhere B and somewhere C. Next second triangle we have the ADC. So now keep in mind here, angle A is congruent to an angle D we have given, so that here we have the D. C be the common angle between those two triangle ABC and next angle we have the ADC. So we have this as a vertex. Now it will be the B, ADC, so it will be the A over here. So that now I am writing in the given triangle ABC and a triangle we have ADC. First of all, try to show that given two triangles are similar. Once the triangles are similar, sides are in equal proportion, and hence we are getting CA into CA equals to CB into CD. And once we multiply CA and CA, itself 2 times multiplication gives us a square, and hence we have our proof here. So look at once, we are writing in triangle ABC and the ADC. First of all, as per the given data, we have the angle BAC is equal to, means they are having the same measures, means they are congruent to that of angle we have the ADC. This is given to us. And look at the triangle, that angle BCA is congruent to an angle ACD. We can write as a angle C is congruent to angle C once it is a common angle in both the triangle. Here we have to write the name of the angle in terms of 3 letters together. B, then we have the angle C as a BCA here, which is congruent to an angle we have the ACD. Okay, because we have the common angle. Now once the two angles of one triangle are congruent to corresponding two angles of the other triangle, then we can say that given two triangles ABC and the triangle, now vertex A corresponds to we have the D, next to it vertex B corresponds to we have a and vertex C corresponds to C, so that 1-1 correspondence we are writing. Triangle ABC is similar to triangle ADC, means we have now the DAC as per the vertex correspondence by using angle test of similarity. Once the two triangles are similar, then their corresponding sides are in equal proportion. Which sides we required? First triangular side we have the CA, first and the last letter together, so which is corresponds to CD, that to be equals to, we required next side as a CD. So CD means we have already here we are having CD and the AC are the corresponding sides. So look at the BC or the CB. CB with the last two letters together corresponds to we have the CA. So that I am writing we have CB divided by the CA. Try to use the cross ratio test, means we are shifting the CD from LHS to RHS and CA from RHS to LHS, so that we are getting CA into CA, that to be equals to, now we are having the CB into we have the CD. So itself 2 times multiplication gives us a square, so CA square to be equals to we have now the CB into CD, hence here we have our proof, that is CA square to be equals to CB into CD. Now look at the next and last question from 3B. In quadrilateral ABCD, side AD is parallel to the side BC, that means given quadrilateral is the trapezium. Diagonal AC and BD intersects in point P. Prove that AP upon PD is equals to PC upon BP. So look at the AP, PD, PC and we have BP. Those are the sides of the triangle APD and the triangle BPC. So let us try to consider now, once we have given AD is parallel to the side or the segment we can say is BC. So those angles which are formed is in the rotation of Z that are congruent, those are said to be the alternate angle. Once here we have given AD is parallel to the BC, so BD becomes transversal, so the angle ADP and angle CBP are congruent because those are alternate angle. So that I am writing now in triangle, or we may have firstly the angle, which angles we have ADP, which is congruent to an angle we have CBP, because those are alternate angles. Once the lines are parallel, BD is the transversal, alternate angles are formed is in the rotation of Z that are congruent. Now once two lines are crosses each other, means intersecting now in point P here, AC and we have the BD. So vertically opposite angles are formed that are congruent. So we can say now the angle APD, which is congruent to an angle we have CPB. Why? Because those are vertically opposite angles. So let us call them as a equation 1 and equation 2 respectively. Now let us try to consider the given triangles. I am writing in triangle now we have, let us consider APD. Here A corresponds to, we have the C, because A and C are the alternate angles again once the AD and the BC are parallel. ACB the transversal, so rotation of Z formed that are alternate. So A corresponds to, we have the C. P corresponds to itself a P, vertically opposite angle, and again alternate angle we have B and D are congruent, so B corresponds to D, that means here D we have corresponds to B. So look at from equation 1 we are having angle ADP is congruent to an angle CPB. I am writing from equation we are having 1, and angle APD which is congruent to an angle CPB. I am writing the reason behind it from equation 2. Now we can say that the corresponding angles are congruent. Then the given two triangles like APD and a triangle CPB are said to be similar by angle-angle test. Now once the given two triangles are similar, their corresponding sides are in equal proportion. Which sides we required? AP, and now AP corresponds to, we have first two letters together, that is CP, and next side we required for the first triangle, that is the PD. So now PD corresponds to last two letters together, we have the BP or the PB. PD corresponds to, I am writing the PB. Now look at the required ratio. We required AP by PD, so that now once we interchange or the shift CP from LHS to RHS and PD from RHS to LHS, so that PD is the numerator or the multiplier. After all shifting it will become a denominator or the divisor. That means we are having AP by PD. Simultaneously we are shifting the CP. CP is the denominator or the divisor. After all shifting it will become the numerator or the multiplier, so that we are getting CP divided by the PB. Hence we have our proof here. So we have the question number 3 and 3b. So today we will stop here. During the next lecture we are going to continue the question number 4 and 5 from the first chapter.